let's get into this. So let's go over those warm-up problems super fast just to make sure we can simplify our radicals. You're going to see those pop up today, just FYI. Remember, we've looked at this. You can either make a factor tree, totally legit, or use the perfect squares. 1 squared 1, that's not very helpful. 2 squared, 3 squared, 4 squared, 5 squared, etc. Now, A, you should be able to do in your head, because what's the square root of 9? 3 times -2, -6. I like that one, that's a good one. Okay, I'm going to use perfect square, biggest perfect square. If my list of red numbers on the side there, that goes into that is 4. 4 times 3 is 12. Now from here, some of you can do it in your head. I'm going to write a little work for you. Square root of 4, 2. And don't forget you have this front 4. So I'm going to combine that. I'm going to simplify that and make it 8. Square roots of 3. I know you might have done it with less work. Totally fine. 72, the biggest perfect square that goes into that is 36. Square root of 36, 6. And you got the front 6. And again, I'm going to multiply those together. So 36 square roots of 2. Any questions on those? All right, like I said, you'll see some simplifying of square roots. That's what we're reviewing. All right, just to review the process of completing the square. It's been a while. You might have forgotten it. This is all on your note sheet. There's nothing to write down. I'm just going to talk about it for a second. So it says make sure the lead coefficient's 1. Okay, seems easy enough. If it's not, what if you have 3x squared? Well, then you're going to have to divide everything by 3, which that's kind of the one drawback. It could get a little fractiony. I know we love a fraction. Find half of b. Now, where the heck is this b coming from? So they're referencing your standard form of a quadratic. So b, of course, is the coefficient in the middle term. So we're going to do half of that. We're going to square it. We're going to add that to both sides to keep our equation balanced. And that is forcing your left side to be able to factor. That's the purpose of completing the square. We are forcing the problem to put it in a factorable form. That's the reason we are doing it. All right, let's start with some easy ones. Solve each equation by completing the square. Give exact answers, no decimals. All right, so first check, lead coefficient 1. Good to go. Now, here's the thing. This doesn't factor. Nothing multiplies to -85 and adds 20. Even if I wanted it to, it doesn't. So we're going to complete the square. So what I'm going to do is I'm going to first add 85 to the right-hand side just to get it out of the way. I'm going to leave a space here, so just sit tight on that for a minute. Because what we want to do, or what our goal is, we want to recalculate a third term that will make this factor. Now, of course, whatever I put on the left side, you're going to add to the right. We're going to keep our equation balanced. Now, to figure out that third red missing term, we're going to do half of b, and I'm going to square it, which you can probably do that in your head. B, of course, our middle coefficient 20. I'm going to jot it on the side. I'm going to do half of 20, 10, and then I'm going to square 10, 100. You don't have to write that out on your homework. I'm just putting it on there on your notes so you know how I got it. We're going to add 100 to each side. All right, purpose of the 100. The left side now factors. What two numbers multiply to 100 and add to 20? Multiply to 100, add to 20. 10 times 10. So I'm going to be lazy. I'm not going to put r plus 10, r plus 10. I'm going to put it quantity squared. I'm going to add 85 and 100. Now remember, our goal is to solve for r. You've got to get the r by itself. So you have two things to get rid of. The squaring. We should know it cancels squaring. And then we're going to get rid of the plus 10. Okay, what cancels squaring? Square root, so let's root it. Now, squared, quadratic, 2 answers. I have to remember that plus or minus. And then I'm going to subtract 10 off. I'm kind of running out of room. I'm going to put the final answer up on the side there. So I have r equals, I'm going to put the -10 in the front, plus or minus, square root 185. Now before I circle it, the last thing I'm going to check, can the square root of 185 simplify like we did our warm-up problems? That's what I'm going to check now. 185, well, it ends in 5, so I know 5 divides into it. 5 goes into 185 how many times? Do it on your calculator. That's 185 divided by 5. 37. So I know it won't simplify because 37 is what type of special number? Starts with a P. Prime. So we can't simplify, we're good to go. So this is the process you're going through today. Again, the reason why we teach completing the square, this doesn't factor. Even if I wanted to factor it, I can't. So we have to have these other methods. Factoring is always easy if it's factorable, but clearly not always the case. All right, let's take a look at the second one. So once again, even if I wanted to factor it, it doesn't. So we're going to complete the square. First check, leave coefficient 1. That's nice. Let's just add the 36 to get it out of our way. So I'm going to leave some room again. You don't have to see me write plus 36. I think we can handle it. So what we're going to do, we're going to recalculate this third term. So we force it to factor. Anything you put on the left, of course, we're going to balance on the right. Now, let's mentally complete the square. I'm going to do half of b, so half of 10, and then square that. What's half of 10 squared? Final answer, 25. And again, the purpose of the 25, it's forcing the left side to be factorable. So what two numbers multiply to 25 and add to 10? 5 and 5, yep. So let's combo it to x plus 5 squared. 36 plus 25. Now, 2 steps to get x1. I'm going to cancel squaring with the root. I'm going to remember my plus or minus. 2 answers. And then, of course, I'm going to subtract 5 off. Got it. Questions I can answer on this one for you, anybody? Does this seem familiar? Did you do this last year? I'm assuming you did, yes, right? Yeah, that's a good assumption. All right, 2 more. You might be like, oh my gosh, why are we doing 2 more? It's the same stuff. It is, but lead coefficient 8, lead coefficient 4. So these are going to get maybe a little more fractiony, a little more dicey for us. So first, doesn't factor even if I could factor on it. 2 problems. I don't like the 37 on this side. That's an easy one. I also don't like that lead coefficient of 8. Gross. Okay, so let's get rid of that. I'm going to divide by 8. So the 8 over 8's nice. 16 over 8, got it. 37 over 8, ugh, is what it is. 0 over anything, 0. So it's going to be a little worse than the last one because clearly we have to deal with a fraction. Nobody loves a fraction. Well, I probably love a fraction more than you do. Now, same process. Let's move the 37/8. And some of you could do this all in one step and go right to what I'm writing now. Could just skip that and just go into this. We're going to recalculate our third term. So that completing the square part is easy. Half of 2, 1 squared, 1. I'm going to factor the left side. 2 numbers that multiply to 1, add to -2, -1, -1. Now remember the directions. No decimals. Can you add these on your calculator and have it shoot out the fraction form? Sure, I don't care if you have to do it. We should be able to do it in our heads with a common denominator. 1, I'm just going to put in parentheses, is the same as 8/8. So 37/8 plus 8/8 is going to end up with 45/8. Your calculator will shoot that answer out if you do your math, enter, and convert it into a fraction, just for the record. Okay, still going. So I'm going to get rid of the squaring. I'm going to remember plus or minus. I'm going to cringe a little at this 45/8 situation. I'm going to add 1 over. Let's do that. Okay. So now we got a little situation here, my friends. You cannot have the square root on a denominator. Because that square root's over the whole fraction. So we do have a couple of problems here. We're going to have to rationalize the denominator. This is just gross. It's just a lot simplifying. So let's work on this. The square root of 45/8. So really, you've got the square root of 45, square root of 8. Now, you have some choices. You could multiply top and bottom by square root of 8. I'm worried that's going to make it really big, and I don't really necessarily want to deal with that. So I'm going to try to just first simplify them each. So of course I know 45, I'm thinking 9 times 5, square root of 9, or 3. And then of course 4 times 2 for my 8, square root of 4. Okay, that's a little better. Still a hot mess, but a little better. Now I'm just going to rationalize it. We can't have this root 2 on the bottom. That's my problem. The front 2 I don't care about. That's fine. It's that stupid root 2. Oh, Lord help me. Okay. So I think from there I can go ahead and make my final answer happen. So on the top I'm going to have 3 square roots of 10. 5 times 2. Got it. On the bottom, square root of 2, square root of 2, 2. And then you've got the front 2. Got it. It's like 2's everywhere. 2 times 2, 4. Whew. It was a little rough there. So this one just got bad because A, we had fraction work, and we had to simplify that radical. It's like every algebra skill in one problem. You're welcome. Okay? Are they all this bad? No. But you might have a couple on the homework that are, take a little more work. All right, let's take a look at this last one. So first, I don't like the order. I don't like that the 16x, I don't like that. I don't like the lead coefficients 4. We got a lot of problems. So let's divide by 4 and get it in the right order. And try to save ourselves some misery and do it all in one step. So I'm going to have my x squared. Now, 16 over 4. Negative 4x really on the right. I'm going to go ahead and add it over, so it's going to be a plus 4x. So I went ahead and moved it. I simplified and moved in one step. I don't like this 41/4 either. I'm going to put that on the right side. So I'm going to add 41/4 over. So I did like 2 things in one step there to save us some writing. I simplified and I moved the terms in the correct locations. And you can do that too. This is not algebra 1, right? Okay. Let's complete our square. Half of 4, 2 squared. So our left side now factors. 2 numbers multiply to 4, add to 4, 2 and 2. Now again, no decimals, remember the directions. So you could either do this in your calculator, have it kick out the fraction version. I'm going to go old school. 4 is equivalent to 16/4. I have to write the 16 on top. I said it, I just didn't write it right. 16/4, there we go. So 41 plus 16, I'm going to add that up. So that's going to be, oh boy, hope we drop their calculator. I'm going to add that up, 57/4. So you might be cringing with the fraction again, but I think this will actually be a little easier than the last one. I'm going to root it. I'm going to remember plus or minus. Now, let's start with square root of 57. Can we simplify the square root of 57? We can. That's good. I'm happy. Less work. So I'm just going to write that down. I'm happy about this. What's the square root of 4? No rationalizing needed. No radical in the bottom. Bing, bang, boom. Last thing I got to do, just subtract the 2 off and circle it up. Got it. Now again, are they all this bad? No, they're not. But you do have some that take some more simplifying. Now, the other